Mr. Jaideep Mehta, who is the CEO of VC Circle. VC Circle is a leading research and news platform on startups, technology, and investments. And prior to this, for 1.5 decades, Mr. Mehta was in Gartner and in the IDC, where he extensively researched emerging technologies such as blockchain. And he will be talking about blockchain as a sector, right? As an economic sector, what's the kind of activity you're seeing in the industry? What is blockchain? What's the real potential there, the economic potential of blockchain? So I welcome you, Mr. Mehta. The floor is yours.
Thank you.
Let's give him a round of applause, everyone.
Thank you, Tanvi. Good afternoon. I know it's been a long day. Well, I'll try again. Good afternoon. Back there in the expensive seats. Good afternoon again. Hello. My name is Jaideep. Pleasure to be here. And really, it's been quite a fantastic day. Quite a shower of knowledge coming in our direction. Note, I've been following in my current role and in my previous role as well, the evolution of blockchain, which earlier was AKA cryptocurrencies, and then became a byword for cryptocurrencies when kind of Bitcoin hit 18,000 bucks. And then when it came down back to 6 and 5 and 8 or whatever it is this afternoon, then suddenly people said, no, blockchain and Bitcoin are different, right? So it seems to me that our understanding of blockchain tends to fluctuate with the value of Bitcoin. But of course, today I think most of us who've sat in the room would be left in no doubt that actually blockchain is a very useful emerging technology and is not to be ever, so to say, confused with cryptocurrencies, which is but one use case. Now I'd like to just get a sense of my audience. How many folks here are actually from the tech industry itself? Oh, wonderful. Some of you may have heard me 4 or 5 years ago when I used to stand up in these conferences and actually warn the ecosystem, both from a buy side and a sell side, that cloud is coming, be ready for it, right? And the CIOs used to tell me, we're never going to adopt it, it's not reliable, it's too expensive, security issues, data sovereignty issues, and so on, right? You may remember these conversations. They died about 2.5 years ago. And today, if you were to just Google after I finish speaking, of course, you'll find that the cloud ecosystem in India is on fire. I'm standing here before you to tell you that the same thing is now happening. We're at the cusp of the blockchain revolution. The power of this technology is so fundamentally profound that it's going to be unstoppable. And it has the potential to solve so many of India's deep economic and social problems. I'll give you just 1 or 2 examples, and I'm going to try and stay away from what's already been discussed. No point in repeating. There's a friend of mine in Delhi where I live. He runs a company for many years which has been trying to solve the problem of fake medicines at the chemists. I don't know how many of you are aware, but in our country, quite tragically, the estimate that the industry association has is that between 30 and 40% of medicines which are at the chemist shop are actually not the original medicines, they're fakes, duplicates. And that's just lethal. And blockchain is probably the single best technology available to us today, and as it matures and becomes cheaper and is less hungry for computing power, which I'm sure it'll all become, it has the real potential to solve this very fundamental problem. Second example I'd like to give, which has been mentioned earlier but is worth repeating, is anyone who is a homeowner in this country, or even better / worse, depending on which way you look at it, has had the wonderful experience of buying or selling agricultural land in our country, knows what a nightmare the land records are. Right? Now, Karnataka is among those states which is leading the way, but there are several other states which are also now experimenting with blockchain to try and solve the problem of establishing provenance on land records. I mean, I could stand here for a long time and give you example after example. In the logistics space, in supply chain, there's a ton of work going on as well to track and trace food products, for example. Okay? But I think if you take a step back, the really important thing which blockchain enables and engenders in modern society is we re-establish the notion of trust. Today, when you think about the most bizarre phenomena, where you have news businesses, I'm in the news business, right? Fundamentally what VC Circle does is news. And we, in our industry, have profitable, flourishing businesses which are in the business of tracking the fake news being put out by other businesses. Now that is spectacularly wrong, right? That shouldn't be happening. But unfortunately, that is the reality we live in. The second thing which happens so much is this, one of the most popular words these days is this word trolling, right? With the garb of anonymity on the internet, all kinds of crazy things are going on. And also as transactions digitize, as more and more companies adopt digital technologies of all kinds, they many times are transacting with organizations halfway around the world who they've never met, they've probably never seen, they may have even not spoken to. And we have now the glue that can hold this whole ecosystem together in blockchain. And as we travel the journey, as I think through what 2020 will look like, I have absolutely no doubt in my mind, and that is the opportunity for us all in this room to take advantage of. Banks will be adopting blockchain, enterprises will be adopting blockchain, governments will be adopting blockchain, healthcare companies will be adopting blockchain. The use cases will be different. Innovations are going to come at us at a crazy pace. And in prep for this talk, I'll end by telling you that IDC put out some very interesting market size numbers. In 2018, they estimate that the blockchain market in the world is going to be $2.1 billion. By 2021, which keep in mind, ladies and gentlemen, is only 3 years away now, they estimate that the market is going to be $9.2 billion. You're not going to find a whole bunch of markets in this world where the adoption of a certain technology is so rapid that the market grows 4x in only 3 years. The opportunities before us as individuals, as businesses, as society, and as government to take advantage of this wonderful new set of tools available to us to solve a whole bunch of our problems. And today, as I leave the stage now, you're going to see some amazing work being done by a few startups, but I won't take the thunder away from them or from Tanvi either. I congratulate the whole ecosystem today. You've done a tremendous job in really evangelizing and throwing the spotlight on a critical new technology set. Thank you for listening to me sort of so patiently. It's been wonderful being here, and with that, I'll conclude here. Thank you very much.
Now we move on to seeing live demos, and I think I'll give you a brief over what happened in the hackathon. There were essentially 5 use cases that 80 teams sort of worked on. The first of these use cases was around multi-stakeholder decision making. So how can you have a lot of different agencies and public sector, private sector, even within the government, many agencies, how can they leverage blockchain for decision making? The second theme was around this whole traceability of commodities. So if you take things like timber or organic produce, how can you leverage the blockchain to keep a lifetime record of this asset that's moving through so many parties? The third theme that we looked at was identity management. So really, how can you give the power back to the citizen in terms of his own data and his own information? How can the blockchain be leveraged there? The fourth one was around subsidies and incidence-based payments. So if a citizen meets certain criteria, like he's under BPL or he is from certain groups or he is under certain conditions, how can the government send him a subsidy? So these were the fourth case, and the fifth one was around record maintenance, right? And this is where the land record sort of use case comes in. How can you keep real-time copies of records, which the government maintains so many data registers? How can they be made real-time such that so many stakeholders always have access to the true value of any record? And with that background, I think in terms of participation, as the minister said, as many speakers said, It was unprecedented. I think this was one of the largest blockchain hackathons in India till date. And thank you. And from this whole, from the Hunger Games, 10 teams emerged victorious, and they will now be presenting their concepts. So without any further delay, I will call on the winners of this hackathon, the ones who won from amongst all the 80 teams. This is Team Bitgram, and their solution was on the issue of identity and data privacy on identity. So Team Bitgram, the stage is now yours. So they will have a short presentation, about 3 minutes, 3 to 4 minutes, and then there'll be time for audience questions.
This is Priya representing Team Bitgram. We've spent around 15 years each in deep technology, in extreme auditability, data transparency, data privacy for large organizations like Oracle and Accenture, and regulators like the US FDA through them. So we understand the importance of extreme auditability, and that's our passion. We have 2 patents on data intelligence and data privacy. So today, I would like to walk you through a small story of Madhapa, hardworking truck driver who travels interstate, and his wife, Devamma, who is a vegetable seller. So these are the people who have eligibility for finance. These are the people who have eligibility for access to subsidies, sorry, but they don't have time to leave their jobs where they're sitting and go and get services. They don't have time to go figure out who is the department I need to talk to and where is the bank that can give me services. So that is the problem. In fact, there is a study which says $2 billion are lost every year in India alone in foregone income. That is the time it takes for people to travel to and from a bank. And that is a lot of money. So this is one side of the story. On the other side, we have our citizen-centric government who is releasing subsidies and schemes for people, and they face 2 main problems. One is they don't get access to the rightfully deserving people. And the second problem is, even if they do, to figure out if the subsidies were being utilized for the purpose that they were given for, and also to figure out if there were no frauds that happened. So, is there a solution that can solve both these problems, Madhapa's and the government's, gracefully? I'd like to introduce the super identity. This is an artificial intelligence and blockchain-based software product. So we've kind of used the best features of AI and blockchain and figured out a way to make a product that is going to bring immediate business value. And using the super identity, the mission is to make lightning-fast exchange of trust between businesses, governments, and citizens a reality. So using the super identity, you can combat frauds and forgeries, asset duplication, and misrepresentation of identities, all of this in real time. So why do you need a super identity? Why do you need a blockchain? And why can't I just put Aadhaar on the blockchain? So to simply summarize in 3 points, a traditional blockchain, by virtue of its decentralized nature, makes me, as a node, share everything I have with every other node. Now, no bank would like to do that. No government would like to do that. So using the super identity and the knowledge that this is the case, we have designed an anonymization layer using which all the participating nodes can talk to each other on a consent basis and selectively share information that is relevant for business and not everything. The second problem is, while hashes sit on the blockchain, the actual documents are still outside. So that is a vulnerability, and encryption may not be sufficient because you're talking about blockchain as being a superior secure solution. So during the hackathon, we designed double-blind obfuscation algorithm. So to summarize it in one line, we cut up the documents digitally into multiple pieces, randomize them, encrypt them, and distribute these pieces across the network so that only an eligible person or the authorized person who's to access that document can get access to it. Problem 3, the uptake of any new technology entails a cost and time. So problems like, will my legacy systems work? Will I have to do a lot of compatibility analysis? Will I have to change processes? Will I have to train people? So Being mindful of that, we've architected the Super ID to be fully plug and play, which means you have simple API calls, and even legacy systems can talk to the Super ID by just calling APIs. So that's the business side of the story. And from the citizens' perspective, people like Madhappa, who are semi-literate, who cannot rely on knowing complex English sentences like the consent request, should still be able to use it by just using a mobile app. So I will quickly demonstrate some features that we want to show. Intelligent recognition is something that uses AI and figures out the type of document from the picture that is clicked. So using this, you don't need to specify that this is an Aadhaar card, this is a passport, and so on. And because the AI can figure out what document it is, it can pick relevant information from that document and directly feed it into the back-end forms of a business. So that brings value to the business because now they don't need manual people typing it out. And of course, people like Madhappa should not be denied eligible services simply because they don't know a language. So regional language support is important, and we are building Kannada and Hindi to start with. So this being the user side of the story. From the business perspective, it's a simple 5-step process. When, let's say, a government subsidy office signs up for a node, they get immediate access to continuously updating verified information bits. And let's say a government officer onboards a citizen using a set of documents. Our AI immediately validates these documents at scale. So you can think of one person sitting and doing it manually versus an AI doing like 2,000 validations in a second. And then comes the beauty of the super identity. So because a super ID has information beyond what the subset of documents have told you, we can piece together all the dots and figure out if there are frauds, forgeries, if there are inconsistencies that can be flagged off to the business. And finally, we construct a portable standard box on the blockchain, which we call the super identity because it is a sum total of who you are in the digital space. It is your digital DNA. So now the benefit is banks, businesses, governments can get real-time verified information and can prevent fraud. So it can be prevented from happening in the first place. So that way the potential to save a lot of money, and that is huge. So we also promote data sovereignty. As people from the data protection space, we're passionate about this. So we think users and citizens are the owners of their own data, so they should have the right to revoke information, to consent to information access from businesses. So that is what we've built as an architecture in the product. And of course, we leverage the India stack fully, from Aadhaar Auth to DigiLocker, eKYC. And we want to be a cross-industry protocol for identity intelligence, which means different domains like the healthcare and the education and the finance can talk to each other through the super identity. So that is the vision. And for the pilot, we have proposed the following. So you don't have to read it, I'll just summarize it. The government issues subsidies on their delivery platform using the blockchain super ID. And after they do that, each citizen gets a super identity. Now, every document and everything that they're collating is processed through the AI and put on the blockchain. Now, the government can monitor these subsidies, the disbursal, the usage, and everything on the blockchain in real time. Once they do that, to experience the full beauty of the blockchain for decentralization, invite third parties, bring in microfinance institutes, bring in insurance agents, bring in hospitals to serve the same individuals using the super identity by reusing information from the super identity. And that is going to demonstrate how a blockchain can be used instead of a centralized system where ownership is restricted to one party and the other parties need not necessarily trust that person. So now once we do that, we would like to benchmark how much time was saved, how much money was saved, how many more customers were reached and accessed, and how much fraud was prevented. So we are the world's first global protocol for identity intelligence, and we are a Make in Karnataka product, born here, brought up here. So we would like our government to be the pioneer in showcasing the super ID to the rest of the country and to the rest of the world. I'm thankful to be here, thankful for this opportunity, and a big thank you to the judges and the mentors who helped us through the hackathon, and your encouragement has brought us here. So thank you very much.
So now we had 2 second prize winners, and I would call on the first team that won the second prize. That's Team RX Chain.
Hi, I'm Akash. This is Siddhant and Alankar, and we are Swiftace, and we have created a product called Aham, which is a secure identity management platform. So over the past few years, we have seen a lot of benefits of digital identity systems like Aadhaar, such as paperless KYC, biometric authentication, demographic data verification, and document account linkage, etc. But these systems have had their fair share of concerns. One of the biggest concerns is the central data repository. Right? So this central database is like the treasure chest that all hackers and attackers want to get into and get the data of people. It may be encrypted, but it's currently encrypted with like a single key. So if that key is compromised, or if somebody who has access to this abuses their privilege, then it is still possible to have leaks. And some concerns like that have been raised recently. One of the other concerns is that we do not have a lot of visibility and control over who gets to see our data. We don't know what exactly people see. We don't have the ability to share parts of our data. We don't know when it has been accessed once we have granted the access to it. And we don't know if it can be revoked, and if so, how. So this is what we thought about during the hackathon. And we decided to come up with a solution that gives the ownership of the data back to individuals, while still providing all the benefits such as eKYC, document verification, authentication, etc. Now we'll have a technical demo soon, but to motivate this, let me offer a simple analogy. Today, when we register for Aadhaar or sign up for a bank account, our data is taken and put into a central database. But suppose instead of this, suppose the issuing authority, instead of putting it into a central database, gave you a private locker, which was kept at a secure location, and only you have the key to that locker, right? So every time, so you have access to your data, you can go inside, access your data, come back, lock it there, and if somebody else needs access to your data, it's fine, you can take them with you, go inside to the secure location, so it's all logged, who comes in, who goes out. You go inside, unlock your locker, show them the data that they are interested in. Once they're satisfied, put the data back inside, lock, come back, right? So this is the kind of solution that we wanted to create. And to take this to the digital world, the private locker becomes RSA cryptography, and the access logging at the secure location, that becomes the blockchain. So there are 3 key stakeholders in our system. There is an issuing authority, like the central government, which collects some demographic biometrics, verifies them, and issues the document. There is the user, who is the owner and custodian of the data and gets to decide who accesses their data, what they access, when they access, and also revoke access. And then there is a service provider who can make requests for specific parts of data from the user. The process is performed, and the document is stored in an encrypted format, and the hash is written to the blockchain. On the user's phone, the user can see a list of all the documents that they have been issued. And when they open a document, the encrypted data is downloaded, decrypted on their phone, and shown to them. So here you can review requests from all service providers. You can see what exactly they have requested and for how much time. And then once you approve the requested, your data is encrypted, uploaded, and then an approval is written to the blockchain. At this point, the smart contract is updated, and the person who has requested the data can actually view your data. So essentially, apart from the existing benefits such as eKYC, authentication, verification, we have these additional benefits of the system. One is the ownership and access control, which now belongs with the user and not with some central authority. And then there is no single point of failure, again, because even if that data is compromised, all the data is encrypted using users' private keys. It's tamper-proof, and there are verifiable access logs. You can see when a document was issued. You can verify that a document is accurate, issued by the government, and up to date by simply looking up the hash on the blockchain. And at the same time, you can also provide a selective and time-limited access to particular fields of particular documents. So this is a brief intro about our team. Thank you.
Now I'll call upon the second winners who won the second place. That's Team Chain Walkers. And they worked on the issue of real-time record maintenance. So this is the land records case.
Thanks a lot. So we are team Chain Walkers. We worked on decentralized autonomous land record management. We are from IBM. We picked up this specific land record management because I'm sure everybody here would have gone through the land deals at some point of time, and you know the pain points that we need to undergo. A lot of what you call as disconnected systems and everything we need to go pillar to post to get that thing done. So what we proposed was an architecture as well as a solution, which we call it as registration seva kendra, where an user can register an intent of selling it, and the registration can happen in a kind of an ATM kind of place. That's what we proposed. So I'm going to quickly go through the logical architecture, mostly technical. So the core of it is we use Hyperledger. So we visualize the nodes to be the nodes like Kaveri, Bhumi, and land acquisitions, which are typical organizations or entities which are involved in the land record management system. And there could be many more, but as an illustration purpose, we have this much. For storing the records, the documents we considered IPFS. So it's a kind of, again, a distributed storage system. It's an hash encryption. Like most of my friends talk about hashing. That's pretty much same that we have. Rest of it is exposed through a set of REST services where a user or probably the systems would interact, will have on REST APIs or event listening system. Everything is a kind of a Node.js application is what we visualized. This is the Bhumi application. We also called it as Dharti at some point of time. So where this is just a view only, where you can view mutations and stuff like that, the history of lands. So we visualize that it directly get connected to a Node.js application. Internally, it is connected to one of the nodes of the Hyperledger or any DTL technologies. We also look at the registration office. Here we slightly differentiate from others, where we do know that there are certain records or probably the certain amount of data which is specific to the land registration authority. So we said that is centralized and that will not be shared across. So what we said was that becomes what you call as end user or probably the registration authority application, but underneath you have blockchain operating for sharing the data, which are very common to other nodes which have interest in looking at that data. So that's our architecture. So the land acquisition app also, it's in the same fashion that get integrated into the system. And lastly, we were looking at other facilities like building a buying and a selling portal, where they could really utilize one of the nodes within the Hyperledger, and they can use for validation and verification processes. But the rest of the records, the request for buying or selling, all those things would be up in their own centralized system. That's what we visualized. I think we will move on to a demo section. This is purely from an architectural perspective. Moving on to the demo section, where we have the Dharti Land Records portal, which is connected to the blockchain environment. Here you can just really look at the RTC or mutation. different searches are possible, search by map, search by... So what we are talking is about different searches that are possible. You can do a Google Map kind of search, or you can do search by an Aadhaar, if it is, Aadhaar is again validated, or you can just search by the owner's name and the PIN code and stuff like that. If it is unique, it's going to pop up a record, and in this case, it is a property which gets shown up. So here you can even visualize from a map perspective. We have not shown the exact details of how the land and stuff like that because we do not have the data for it. But if the data is available, we can really bring up that piece of land. So that's the search we have, and also we have history which talks about mutation. So this would bring up all this stuff. This one is the Land Registration Seva Kendra, where this is something similar to Passport Seva Kendra, where we bring up, there is an app where you can register an intent of a sale, rather than we going and then bringing up applications for registering. So one can register his intent. So this is the user, maybe this is another login that he is logging into. And this will be authenticated through OTP and stuff like that. So what you see here is the property that the person owns, and he can really say, I will begin the transfer. So this transfer is just an intent of transferring it. So once he clicks on that, he will have to fill up details. So he can really fill up the buyer details, the witness names and stuff like that. He could even fill up Aadhaar, and we can pull up all the details here. And he can, the deal location is again a set of ATMs are probably the registration offices where it will be a drop down where they can pull up, and then they can clearly put the intent over there. So once he submits, he's going to get an appointment, which is an appointment ID. This is the appointment ID they need to carry, and then they can get into a kiosk where they can do the real registration. So again, if you really look at it, it is what you call as there are no middlemen here, and there is also no human intervention here. It's purely a system-based registration that we are doing. Once we get into a land registration Seva Kendra, something like an ATM, so we need to key in the access token there. You can just click on proceed. What happens here is that it brings up all the details of it, and also you can really do the payment. The payment details can be filled in, and you can instantly do the payment here. And also the buyers and sellers, the biometrics can be done. In this demo, we have not shown this, where these details can be put in. And once everything goes through, we just need to fill up the details of the buyer name and all the details. We can, again, as I said, we can pull this up from Aadhaar or any other identity solution. So all this stuff can be auto-filled since we have Aadhaar and details. So you can just start about transfer ownership. So if the payment process is complete, the transfer of the property would become automatic for them. So you really see that we really want to eliminate the human intervention here and also the middleman over here, and that was our idea. Thanks.
So the third prize winners, there were 3 winners here, and I call on the first, which is Team Bayesian Conspiracy.
Hello. Hi. So we are the Bayesian Conspiracy. I am Vivek. This is Srijit. This is Aditya. This is Samideep. We're all friends from college. Now we work and try to do hackathons on weekends. So about the hackathon, we really loved it. We had absolutely no idea what blockchains are, how they worked. We had just heard of cryptocurrency. And whatever we did over the weekend. It was a lot of fun. So what did we actually build, right? So our product is called Blots, expands to blockchain for lots of things. So the problems that we're tackling, there are three fundamental problems, right? So when it comes to agricultural produce, so there is really no way for you to track the quality of agricultural produce, right? Just by virtue of the fact that it changes multiple hands from the farmer to the end consumer, that special properties of these produce, like the organic nature, is a property that is special to some kinds of produce, right? And this property is somewhat lost along the way. And there's really no way for an end user to actually verify if a produce was like organic. If you go to a supermarket tomorrow, right? There's no way for you to actually know. If you really want to know, it increases the premium. Now you need like agencies at every node, so that at every transfer of ownership, you track, okay, cool, like now it is like, this is actually organic, right? And it increases premiums on produce that are actually organic. And from the perspective of farmers, right? Farmers who have these special properties need to invest like delta extra money and time into their effort, which is now lost because they don't really get paid for the extra effort that they do, right? So this is like a very fundamental problem, right? So the other problem we think currently that exists is that there's no way for farmers to leverage best practices in the industry, and there's no way for like, especially the little guys, to figure out like what's really working and what's the aggregate best practice, right? And we think the framework of like blockchain enables both these things very elegantly, right? So how does the blockchain fix it, right? So basically, we have a public ledger. So we'll just walk you through how it works. So I think that will be self-sufficient. So basically, there is a farmer who raises a request for an accreditation by the government. And then the government accredits that guy as an organic farmer, right? So this is a property that now is associated with the farmer on the blockchain. So now whenever a farmer has his or her harvest, so what the farmer does is create lots, right? A lot is the smallest unit that we are tracking on the blockchain. So a farmer on the website that we had built, which unfortunately we couldn't demo right now, so the farmer goes and creates the number of lots that he has produced, and he puts it up for sale. So now any buyer that wants to buy this particular lot has to sort of bid for this lot with some amount of money that this person wants to buy. The farmer gets that notification on his account, and the farmer has to accept. And when the farmer accepts the transaction, now the ownership of this lot on the blockchain is now transferred to this new entity, which is, let's say, a transporter, or let's say the middleman who wants to buy it, or let's say directly the supermarket, right? So the ownership of this lot is transferred. And the integrity of the lot, that it has not been tampered with, is measured by, base case, you can have nothing, or you can have like IoT devices that maintain it, right? So I'll give you an example. Let's say there is fish. Let's say there is fish that has been farmed under some special conditions, and this information needs to transfer along the chain, right? So what happens is this fishery creates, let's say, 10 lots of this type of particular fish, puts them in a crate, puts like an IoT device, which is a temperature sensor, right? So now there is a smart contract created at the point of the end retailer who says, look, I want fish. I want like 2 lots of fish. I want this fish to come from this person who has a special, let's say, good fish property that has been accredited by the government. This fish should always be transported under 20 degrees Celsius. Like, these are conditions that I put, and I make a smart contract, right? And the contract is executed only when all these conditions are met. And like the IoT device can keep pinging, writing to the blockchain about the temperature in that particular container. So this is how basically we ensure quality without the need of external agencies and high premium along the length of the blockchain, right? So it gives 2 fundamental benefits. So one is trust, right? So now if you look up, as an end user, let's say you go to a supermarket, you see fish, or you see like mangoes, and you see like a barcode associated with the lot that mango came from. So you use your app and you scan that barcode, and you can look up like the entire like chain. You can look up like when it was harvested, like who harvested it, where did it come from, how was it transported, what was the quality of that as it got transported, who bought it, and all of these things, right? You can track all the nodes of transaction, which is, we think, like something that does not happen right now. And because of this, right, what this allows people to do is, because of this bragging right that you now get, that your retailer now gets, everybody is incentivized to be on the blockchain. Everybody from, farmers are incentivized to be on the blockchain because like they get additional benefits for additional effort they put. Retailers want to be on the blockchain because they want to transact on the blockchain because now they have bragging rights, so they can say, look, like I have organic produce that other people can't guarantee you. So we think that this phenomenon of everybody being on the blockchain is extremely useful for like the second purpose that we want to promote, which is analytics on top of the blockchain, right? So this is also something we had in the demo, but we cannot show, unfortunately. So basically, I mean, in our demo, we had all like plain information of everybody displayed, but you can also anonymize it. You can do other things to to ensure like people's private information is not out there. But what we can actually do is we can democratize best practices. So what we mean by this is, so now let's say your seed transaction is happening on the blockchain, your fertilizer transaction is happening on the blockchain, your power consumption is happening, like that is recorded on the blockchain. So what this allows like us to do is sort of understand what are the inputs that went into this farm and what are the outputs that came out of this farm, and sort of like, and that opens up like a huge number of possibilities, right? So now you can do analytics on the inputs and the outputs, and you can democratize this best practices. So people can figure out, okay, look, in this area, this is the type of soil that exists, and this is the type of inputs that give rise to the best yield. And this is the type of price that you get that I didn't get, but like other people got. So I can use that information to leverage and to sort of increase my productivity and be like a more productive farmer, right? Because we think this is like an important link that is missing right now, because isn't it outrageous that farming is such a risky business? I mean, it shouldn't be, right? Like farming should not be risky because everybody needs like farms, because everybody needs food. But currently in the current scenario, farming is very risky, and people like sort of put their lives on the line to farm, which is absolutely outrageous. We think this is like an elegant solution as a byproduct of like allowing people to track the transfer of goods on the blockchain allows us to create this value to farmers, and like this is our product. So some implementation guidelines for the government. We think that the governments can like further promote the use of blockchain by sort of giving subsidies on the blockchain. So now the farmers can give subsidies in sort of a cryptocurrency that can be used only on the blockchain, which then incentivizes, like now seed companies have no like choice, but they have to transact on the blockchain, which then helps our second motive. We think that the governments can also use this as effective SLA monitoring mechanisms. So let's say there is a process that has like a certain SLA, but it's not we can't monitor it. But you can have smart contracts for all of these things. So you can have smart contracts for, okay, this is a sort of, let's say for the initial accreditation process, right? So it typically has to take 2 days. So you can have a smart contract saying, okay, I raise a smart contract. So this accreditation has to happen, and the expiry of this is 2 days. And if it doesn't happen, then like that contract like breaks down, and then the government can track it effectively as to why it didn't. We think that's very, very important. And the third thing is, again, like the analytics can be used to figure out like high-risk behavior. The governments can use it to sort of help only people who are more in need of help. And these are things that you cannot do right now. We think that this will allow people to do it more effectively. So that's it. So we are the conspirators. Thank you.
The next team in the third prize category was CoPro. And they worked on the area of incidence-based payments, basically the subsidy and related systems.
Hi, my name is Advait. I'm from Team CoPro. This is Vinay, Karthik, and Jeevan. We are a bunch of entrepreneurs working on 4 very different things. We ended up meeting on the day of the hackathon and working on a product which we are thankful we managed to finish at the end of 2 days. So the challenge statement that we took was building an incidence-based payment system for the Krishi Protsahan Yojana scheme. This scheme is administered by the Forest Department of the Government of Karnataka. It is meant to incentivize farmers to plant trees on their land, which is an amazing thing. So there are 4 main stakeholders in the entire system. So there's a farmer who requests a nursery, an authorized nursery for seedlings. The nursery then verifies the farmer's land records by checking in with the land record department and essentially releases seedlings back to the farmer. There's a forest department which every subsequent year goes and checks whether the seedlings have survived, and based on the number of survived seedlings, they release a beneficiary list to the treasury. And the treasury releases the payments to the farmer and releases service charges to the nursery. This is how it's supposed to work in theory, but it doesn't really happen in India. So we actually ended up talking to a few farmers on the day of the hackathon. Vinay knew a couple. We tried to find out what the problems were. There were 4 main things which stood out. There were multiple middlemen involved in the process. Even though there are just supposed to be 4 stakeholders, there are a lot of middlemen. And each middleman adds extra cost to the farmers, reduces the amount that he actually ends up getting. There's inefficient record keeping by each department. Most of it is still pen and paper right now. And this causes delays in verification by the forest department, and which causes delays in payments by the treasury. All of it results in the farmer not getting his due at the right time. So how can the blockchain help? So pretty simply, blockchain is a distributed ledger technology, and there are 4 or 5 main ways in which it can help in this situation. So it provides a single database of records, which is transparent to all stakeholders involved, the nurseries, the forest departments, the farmers, treasury, etc. It provides immutability of data, which means once the data has been entered, there is no way you can go back and redo it. You can probably add to it later, but you cannot go and change it. So corrupt agents can't really go and change the data according to their wish. There's lesser bureaucratic touch points. We don't want to eliminate the government altogether. You really need the government to work hand in hand with the farmer, but lesser touch points definitely enables the efficiency of the system. Transparent and efficient dispersal of subsidies. Payment gateways, payment systems can be built on top of blockchain to ensure that the payments get dispersed on time. But the most interesting one we saw was flexibility in changing rates and incentive structures. At the end of the day, all of this works on an incentive microeconomics-based system. A flexibility to change incentives can actually enable the government to experiment with different structures and figure out what actually optimizes the economy. So what we ended up building was pretty simple. Something that we're calling the Krishi ecosystem. It consists of two main things. There's a mobile app for the farmer, which takes care of registering the farmer in a farmer registry, allowing the farmer to request for seedlings from nurseries, self-verification of trees, which goes to the forest department, and also enables them to track payments. And there's also a desktop portal for government officials where they can track seedling requests, track seedling verifications, and pretty much track the entire funnel and see the state of the funnel at any point. We prototyped this on the Ethereum platform. I think till recently, you couldn't run Ethereum light nodes on mobile. There have been a lot of technologies which have come in lately which enable you to do that, so that's a game changer, allowing you to store the farmer's private details on the phone itself instead of on a server. So yeah, Karthik will just take you through the short demo of the product.
So this is the Krishi app the farmer uses. So it's in two languages, Kannada and English, and the farmer takes the, so the farmer details are pulled for using Aadhaar, and the registration is done like the land records and the bank details are put using the Aadhaar, and then the farmer can choose seedlings and saplings which are displayed in the app, and then he can choose which plot to plant the seedlings. And then he can, once the seedlings have been planted, then he can then go ahead and verify for payment, which is like periodically after a year or 2 years, he has to say which plants are still alive and all. And using RFID along with the geotagged images, we can, the farmer himself can self-verify how many seedlings are still alive, so that then each of these process is a smart contract that gets written onto the Ethereum blockchain. So this will be submitted to the forest department, and he can also see the payment status, which lot the payment is still pending, which has been verified. The forest department can then go ahead and verify the plants are still alive or not, and then the treasury department can then release the payments to them. Home page which can show the details of the farmer to the
forest departments, and even the treasury can get access to a portal where they can pretty much track the entire workflow. So all of the data is written onto the blockchain, and its access is dependent on what sort of what they have to do. The treasury will have write access to the payments; they won't have read access to the saplings, etc. So we can literally permission according to the use case. So yeah, the system is pretty fair and transparent. There will be a lot of implementation issues, but we believe that this is the way forward. Literally having a single transparent database where all the stakeholders involved can pull data from and write onto, and which is even exposed to outside government agencies in case of verification, audit, etc. Yeah, thank you.
Is category. The last team we had was Team Builder, and they worked on the area, also the same area of incidence-based payments.
Hi, I'm Shreyas and this is Shabaz. So we have a very short presentation since we took the 3-minute deadline very seriously. And the job is even easier because we also had the same track as the previous guy presented. So yeah. So we called the system as Green Chain. This would be the, it does the monitoring part as well automated, and then the incidence-based payment system is taken care of within the system. Yeah. So as exactly mentioned by the previous team, so the main focus of, the main problems presented by the forest department to us was they have an issue with the monitoring and reviewing the like the number of saplings which are being which are being grown by the farmers. So how to count them? Because what we heard was the number of saplings which are grown are usually in terms of thousands, because every farmer gets close to somewhere around 15 rupees for one particular sapling. So they definitely do it in terms of thousands. So that is in a really large scale. So it would be very difficult for a review officer to actually go and count them. So this entire system currently is actually open for a lot of uncertainty, as in even susceptible to corruption as well. So, and the second problem was even the farmers wouldn't receive the payment as soon as the reviewing is done. So there is a certain amount of delay which would come into picture. So even we have taken care of that system as well. Yeah. So as you mentioned, like the current scenario is like where everything is entirely manual. It's on paper. So there is nowhere any automation or any kind of digitization which is happening. The farmer has to go and get the saplings, and then the review officer comes, he updates it. Forest department asks for it from the treasury department to release the funds, and that is when the farmers get it. So this is our system, what we have planned to, we are planning to implement, given a chance. So the things are the first is the Android application for the farmer, which is bare minimum and very simple to use. It is also available in the local language Kannada as well. So all the farmer has to do is he has to just integrate his details into it, like the initial sign up. That would be providing his Aadhaar ID, and then through DigiHacker we get all his other necessary documents, and then we also have the through the map the farmer can select what exactly is his land, the area of his land. So through that one, we will identify there is a GIS tracking which would be done. So there is something called as Earthcast, which would they provide the satellite images of a particular field, so which was actually fed into an AI machine, which would which is trained to count the number of trees which would be there on the in a particular area. So that is taken care by the AI engine. And then is the blockchain. So I will further going down the presentation, I'll be explaining why we are using blockchain. So, and this reviewing process has to be more robust. So not just the AI alone, because sometimes the AI algorithm confidence score might be below a certain point. So at that time so we need a certain backup to that. So that would be a peer-to-peer review model. So we'll be explaining how it goes. Yeah. So this is how pretty much our architecture looks like. This is the blockchain part where we are maintaining all the records. So starting off with, so the reviewing process need not be happening. Right now what happens is it is done on an annual basis. So since the payment is disbursed only towards the end of the year, so the farmer the review officer goes there from the forest department, reviews the process, reviews the number of trees over there, and then he updates. So that need not be the case, right? So it can happen anytime. So all you have to do is at a click of the button, it takes your satellite images, counts the number of trees, and it's updated. So it can happen as spontaneously as you want. Of course, this part would be charged. And next is the peer-to-peer review model. So let me explain briefly about the peer-to-peer review model. Okay. So what happens is we have tried to gamify this one. If you guys have already played Pokemon Go, so all you have to do is just take your camera outside, you can see the Pokemons standing outside. So it's an augmented reality-based solution. So wherein the farmer would just take out his phone. Through the camera, you can see that different kind of farms are there, which are the close-by farms are there, which you can go and review it. So of course, the guy who will be reviewing it will be incentivized. So, and that is through the blockchain part, because all his data is being updated in the blockchain. So the farmer will be, the guy who will be reviewing it, right? He'll also be incentivized. That is also taken care in the blockchain. And the GIS data, as I told, it can be, the photos can be taken at any point of time, the images can be taken at any point of time, and data is updated. And the smart contract is as such, wherein you have to just the terms are already set. So how exactly a smart contract works is, it's more like a actual real contract what we have in the daily life. So you do a certain task, I'll pay for you for that. So right now here it is, you grow these many saplings, you'll get paid for it. So the contract is already on the fly, the code is already on the fly. All you have to, like as soon as the year, the calendar year comes to an end, so the payment is already extracted from the treasury department, and but the farmer gets paid only for the number of saplings which he has grown. That numbers are coming from these two users, and the remaining amount, like whatever is the Y number of the saplings which were either dead or which were there in the actual count, the payment would be disbursed back to the treasury department. So yeah, our tech stack looks something like this. Yeah, so these are the different users who are there. The farmer and the peers and the forest department, nursery, treasury department. So every time farmer creates, he approaches the nursery department, once he gets the saplings, that is when he is in the part of the process. That is when his contract gets fired up. So that's pretty much this. Yeah, so our AI algorithm, it would not be very straightforward to use it because it needs a certain training to be done. So this is how it exactly looked. We took around 4 hours to train an image such that it could pick up and try to identify what are the number of trees which are there. As I told earlier, the confidence score might vary based on the image quality and some imprecision which might be there in the algorithm itself. So to back that, we have the peer review model, and then the final result can be actually the manual review process which the forest department officer has to do. So yeah, one very usual question all the teams would get is why blockchain? Why is that we want to use blockchain for to address this particular problem? So the thing is the entire part, if you see over here, is the farmers are not receiving the payments at the right time. So there is a certain amount of delay which happens. So that can't be negotiated. If this is fired as a smart contract, which I'll tell you very briefly about what is Ethereum and Bitcoin. So in Ethereum, you also fire up a contract, not just the value which is being part of the transaction. As a part of every transaction, there is a smart contract which is there. So that code is on the fly. So the rules are already set. So it can't be negotiated whatsoever. Only the values can be changed, but your terms and conditions are set. That is the first main use, this one, main point why we want to use blockchain. And the second one is, since we are using the peer-to-peer review model, blockchain is the best way to implement this peer-to-peer review model. And yeah, so this entire process, that is just an estimate number, by the way. Using the Earthcast service, that is where we would come up to for per review to happen. And yeah, as I told earlier, it is the review model. We had taken care such that the entire system is bare minimum and simple to use with hardly few clicks. And yeah, it's like a peer-to-peer review model would be there with certain incentives. Yeah, that's it. Thank you.
Which won in the 4th place category. The first is App Boot Up, Team App Boot Up. They worked also on the chain of custody for agricultural produce.
Hey folks, we are Team App Boot Up. I am Pranay, this is Sachin, and this is Nitin. So we have worked on the problem of tracking mango across export supply chain. So this is the story of Mohana, who is a mango grower in a village in Karnataka. And the problem he faces is that he has no good way to prove that he doesn't use any chemical in cultivating his mangoes. Also, he doesn't find the right prices for his buyers, and he has to depend a lot upon the middlemen to find out where can he sell it and what are the good prices he can get, right? And as a customer, we always feel the problem of when we go to a market, we see that there are so many oranges, and people claim that it's all organic, but we always have a doubt that are they really organic? And people claim that this is from a particular place which is supposed to be a good mango, but are these mangoes really from those places? So this is the problem which we are trying to address. To get slightly into more detail, this is the simple export supply chain which a small farmer has. So for the farmer who produces the mangoes goes to an aggregator where the mangoes are sorted, and then the chemical tests are done to verify that it is actually organic or not, whether pesticides were used or not. Then it goes to exporter where he does some other checks and he assigns certain certificates upon about the quality of the mango which is there. And then this exporter finally makes lots, and then this goes to the importer, right? And from the importer, it goes to big super chains like Whole Foods, and from there, it's being bought by the users, right? So the key problem in this case is the lack of trust among the players in the supply chain, right? As you saw, there are different players in the supply chain who have different incentives, and there are lots of intermediaries in between. So that's the key problem which we wanted to solve. So this is the solution which we proposed. So basically, there's a farmer who basically grows mango, then he goes to aggregator and he creates lots of it. Now lots of this is tracked across the supply chain, and these lots and the digital certificates assigned to it are tracked on the blockchain. And now in this blockchain is run by different nodes. The nodes of this blockchain are run by aggregators, the exporters, the importers. So basically this ensures that everybody who is part of this blockchain has seen through all the transactions and can verify that the details which are assigned to a particular lot are correct or not. And then the new idea which we introduced here is that of a feedback, right? So if the person or the retail end consumer who consumes the mango, if he can give a simple sort of feedback to the customer, to the supply chain about the quality of the mango, then this can be used to create the rating of the whole supply chain, right? So if the mango is organic or not, and if he gets a good rating, the credit rating can improve. So in a way, we try to build a sort of credit rating in the whole ecosystem, which is very lacking as of now. As of now, the whole trust is built upon the very informal methods of trying to find credits. So that's the key part of our solution. To get into a bit of technical details, so we built this solution on Ethereum private blockchain. Basically, different players would have access to smart contracts, which will be accessible only to them. So these smart contracts are nothing but simple codes which run on blockchain. So these are not running on a particular server, but they are running on the blockchain, and only specific people will have access to these contracts, right? So the packers who want to assign certain digital signatures will be able to access, update those functions. Exporters will be able to update those functions. So basically, we can track which lots a particular lot went through which of the suppliers and trackers, and basically get the whole supply chain, track of whole supply chain across it. And because this smart contract is deployed on the Ethereum blockchain, it's very decentralized and in a trustless manner, and basically people can trust each other, right? So why blockchain, right? So the whole idea of using blockchain is such scenarios that because there are multiple parties involved here who don't trust each other, right? If there had been trust among the parties, there's no need of blockchain actually, right? Because the central server can hold the data. But because these are parties who don't trust each other, we need a blockchain so that they know that they can verify all the transaction going in here. Also, the other advantages which blockchain provides is that it's immutable. So at any point of time, nobody can erase the certificates which is assigned to a particular lot, and it can also be audited. So finally, the benefits which this system provides is that it provides a complete track of the supply chain, which are the exporters, which are the packers, which are the importers, which a particular crate of mango has gone through. What are the certificates each crate of mangoes has? So you can always go to the blockchain and verify what are the certificates it has. The credit rating, right? So the credit rating which a product gets can be used to provide beneficial financing to the farmers. So this can build a sort of eco-ranking rating for the farmers, which can be used to give them credit at a cheaper rate. And finally, because we are tracking lots of features on the blockchain about each of the product at a very granular level, it's not just that it's good mango or bad mango, but what are the level of certifications they have, is it organic or not, and what are the level of pest compliance they have. We believe that this tracking all this data on the blockchain will create a market which will value these products. So because of the availability of data, a more innovative market will produce, which will provide more value to the farmer. That's it. That's all for us. These are our contact details if you're interested.
We'll have Team Belfrix. They were also 4th place winners, Team Belfrix. They worked on the issue of ID management.
We are from Team Belfrix. So who are we? We are a global cryptocurrency exchange. So on a lighter note, I would like to start by asking you guys, how many of you guys own a cryptocurrency? Hands. Okay, for those of you who don't own, you know where to go. Okay, so as many of you out here, even I thought identity was boring. So I thought I'll come to a hackathon and figure out what identity in blockchain looks like. So we spent good enough time understanding what identity is and what can be done with respect to identity on blockchain. So what we figured out is identity is required wherever you need to identify yourself. So within a business transaction, if you look at it, there are people, there are identity issuing agencies like Aadhaar, PAN card, and passport who try to actually verify your identity. And me as an end user want to get identified. Why do I want to get identified? I want to get identified because there are the service providers who give me services by looking at my identity. So this is where identity, if you try to narrow down identity in a business perspective, right? This is how identity is perceived in a business perspective. So since we hail from an exchange, I would like to take up on a case and then try to explain what we did with identity on blockchain during the hackathon, right? So this is this is how it looks, right? So if you look at SEBI or someone who is actually trying to list an exchange today, Nifty, you have Bombay Stock Exchange. If you look at these exchanges, you have someone who is a regulator who tries to regulate your exchanges, and then you have end users whom each of these exchanges try to register. Now let's look at a user called Alice and see if Alice is a user of 3 such exchanges, right? So let's see how we could simplify life for Alice, thereby simplifying life for everyone. So this is a pre-blockchain era where you have your name and all your information, which you try to manage through your passwords. And then post-blockchain, you'll be having your private keys, where you use the private keys to transact on blockchains. Yeah. So one thing, so if you have heard me talking, like one thing that I was actually trying to stress upon, or one thing that I actually figured out is, you have attestations. Like if an identity organization is trying to figure out who is trying to say this is Raghu, right? What it is trying to do is it is trying to attest me that this person is Raghu. So one thing that we actually tried to simulate from our current existing network onto blockchain network is attestations. So you have Alice. Alice has information such as name, date of birth, and address proof. And Alice controls all this information using her private key. And now you have identity. You have an attesting authority. For example, SEBI in India, instead of an exchange like Belfrix trying to do a KYC for each and every user, right? So if SEBI could say this person is actually compliant to transact on a cryptocurrency exchange, instead of a person going to each and every exchange and trying to do it, so that makes life easy for Alice. So that is what we tried to actually modify. You have a attesting authority who tries to attest a given user, saying that he is compliant to transact, and the user can go share this information with each and every organization or an exchange that he wants to register in. And now, so this is what we did. What did we use? We used Hyperledger. Why did we use Hyperledger? Because it's one of the most vetted code base out there. And then it has something called as channels. A channel is nothing but a private blockchain. Now, end user, if he's transacting with an attesting authority, right? He is nothing but he's having a own private blockchain with respect to that particular entity. And now, if he wants to share this information with anyone, he can just take this piece of information and share it on a need-to-know basis. Yeah. So we as an exchange, we are also a blockchain company, and we have our own public blockchain, which is called a Belrium blockchain. And And within this Belgium blockchain, so this is where the user attestation actually happens. This is where your trusted node actually says Alice is compliant to do a transaction on a blockchain. And then, for suppose if Belfrix wants to use this identity in order to decrease the operation cost of a given user of their business, right? They need to know for a fact that this person is actually sharing information with my business, and they should be able to store this information. So we use a public blockchain to actually store this information, which companies can actually go for, which companies have a source of sharing, where companies have a source of sharing as well. And then why all this stuff? What are we trying to do here? What we are trying to do is we are trying to enable peer-to-peer transactions using identifiable endpoints. So about Belfix, we started in 2014. In 2016, we had our first exchange in Singapore. And then 2017, we had our India exchange. 2017, we had our ICO. We have our own coin, which is called Belgium token. So next month, we're going to launch our own blockchain, which is called Belgium blockchain. And these are the verticals we are in. We are a cryptocurrency exchange. We give out white labels to whoever wants to boot up their own exchange. We have algorithmic trading models. And then we are into blockchain solutions. We have a KYC-based blockchain, which is compliant, where end users are actually identified at a blockchain level. And then we are also trying to compete with who's of the industry in trying to enable blockchain-based remittances. Thank you.
They are the last of the winners. They worked on the cross-domain decision-making issue, the tree felling problem.
Hello guys, I know it's been a long time and I see very dull faces. So I was just going through the jokes on blockchain. So there was a joke like how many miners will be required to just change a light bulb. And the answer was 1 million. One to change it and the rest to just verify the change. Yeah, so we are bound by the rules of the 3-minute video, so we won't be giving lengthy presentations. We have a video in place that is quite interactive, and we'll take up the follow-up questions after, if you have any, after the video is over. So, so it is just a very simple architecture. You have a Hyperledger blockchain setup, and the node for each of the blockchains or the peers is for the respective departments, like the forest department or the revenue department. So that is a Hyperledger blockchain network, and that is being interacted by a REST API over HTTPS, and we have separate portals for farmers as well as for the forest department. For all the departments, we have separate like login profiles, and if you see, there is the new thing that we try to do is we try to have a conversational platform.
So we are trying to help farmers to conversate with our system in a very easy way. So as farmer is not a techie guy, and it will be not feasible for him to go on the web app and again see his transactions. So what we have built here, so a simple chatbot based solution with the help of which a farmer can just type their queries like whether its request is permitted or not, why it's not permitted, or those kind of queries will be there. So that chatbot will be able to communicate with our blockchain and get the status reports for the farmers. And also we are trying to bring the proactivity of the chat with the help of chatbot. So farmer need not to ask again and again. So once the transaction goes to the next step, farmer automatically get a notification where he'll know that your transaction is permitted or it's rejected.
Yeah, so that is it, and we are storing the documents like in the IPFS cluster and their hashes in the blockchain, and we have like Hyperledger Blockchain Explorer to just monitor the health of the blockchain, like how many blocks are there, what are the number of peers, and what are their addresses, and we have separate portal for RTO and for the timber management tracking. So once a tree is cut, then it has to get a transport permit, then that has to be tracked by RTO. So in the future extensions, we are trying to incorporate the use of IoT devices as well, so that when you just put the log or the cut log in the truck, so it can just detect what is the weight and what was the granted permit of the weight, and then based upon how many checkpoints or the places where he has passed, the RT department can monitor like where the truck is which route the truck is taking. So we can monitor all those activities in the future enhancements that we propose in this solution. Yeah, so we can go ahead.
Now farmer can log into the system and create a request for a new permit. He requests for a new permit and sees the details of land that he owns. All this information is coming from blockchain. He selects a tree to cut and gives the purpose. This request goes to forest department. As a transaction is made in the blockchain, so the number of blocks and transactions is increased. Now a guy from forest department can log into the system and he sees already existing permits. He selects the permit and the relevant permit information comes from blockchain. Because of trust and transparency that blockchain provides, forest officer can take a decision on whether or not to accept the permit. He does not need to consult various departments as the information is already in blockchain. Thus, it saves him time and money. So, forest officer can finally approve the permit. As this causes another transaction in the blockchain, a new block is generated. This can be seen by this dashboard. Now farmer can use Blogi, the chatbot, to know the status of his permit. He does not need to open the web application. Also, there might be a case when internet is not available to the farmer. In that case, he can simply send a SMS to the bot and the bot will respond. Now the farmer can raise a request to RTO department to move the trees that he cut. RTO department can monitor the route that he took in real time, and the GPS coordinates of the route will be stored in blockchain. This can be used for future verification.
Very patient audience. So now we've come to the end of our day, and we will have the award ceremony.